In this video, we're going to learn how to solve quadratic equations by using our knowledge of square roots. So let's start by reviewing how roots and exponents all work. So here we can see that we have x squared is equal to 9, and we're trying to figure out what x is equal to. Well, hopefully, with your knowledge of algebra, most of you are saying, well, x is equal to 3. And while that is true, there's actually a little bit more to this process. So here, keep in mind that a squared function turns anything to be positive. So 3 times 3 gives us 9, but in addition to that, negative 3 times negative 3 also gives us 9. So we have two possible values that are here for x, and we need to keep that in mind as we're solving problems later today. Now, the other thing that you need to realize is that we have an operation here that we can use to undo a squared. So if you ever want to undo a squared in a problem, you are always going to undo it by using a square root. But what you also need to remember is that when you square root a squared, so when you square root a squared, we just talked about how there are two answers. So there are going to be two answers here. And the way that we typically write this in Algebra 2 is when we square root a squared, we have x equals, and then we know that the square root of 9, we're going to use the positive and the negative version of that, as you can see down here. So we would typically write our answer as x is equal to plus or minus 3, which means x equals a positive 3 or x equals a negative 3. So we're going to be using this new notation as we use our knowledge of the square root and squared functions and solve equations that contain squareds within them. So we're going to use this knowledge as we solve the following quadratic equations. And note that these are quadratic equations because their highest power for a variable is a squared. So keep that in mind. They're quadratic. So we're using our knowledge of square roots to solve quadratic equations. Now, in order to solve either of these quadratic equations, we need to get the part that is squared alone. So in this case, we need to get x squared by itself so that we can undo that squared function. So we're going to start here by adding 40 to each side in order to get that squared alone. So we have 5x squared is equal to 40. And then we divide both sides by 5, and we get x squared is equal to 8. So now we need to think through how we're going to undo that squared function, and we know that we can undo the squared function by using a square root. However, we also know that there are two numbers that when squared give us 8, a positive and a negative version. So we're going to write our answer as x equals plus or minus the square root of 8. So we're using our knowledge of square roots, and notice that we're not using a decimal answer here. We're leaving our answer as its simplified square root. So what we need to do here is we need to make sure that our square root is simplified. And if I look at that 8 underneath the root, I notice that 8 is divisible by the perfect square, 4. So now that we have this plus or minus piece out in front and we're accounting for both the positive and negative solution, we also need to simplify this square root. So this becomes still a plus or minus. So it's 4 times 2. So that becomes plus or minus the square root of 4 times the square root of 2, which gives us x is equal to plus or minus 2 square roots of 2. So now if we look over there at example 2, again, our goal is to get this part that is squared by itself. So we're going to add 10 to both sides. So we have negative 2x squared is equal to negative 40. Divide both sides by a negative 2. We have x squared is equal to 20. Now at this point, I need to get my x value by itself. In order to undo a squared, I need to square root both sides. Now when I square root a square, I know that there's two possible answers. So I know I'm going to have plus or minus the square root of 20 as my answer. Now from here, I need to make sure I have a simplified square root. And if I look at 20 and I think about all of the perfect squares, I know that 20 is divisible by the perfect square of 4. So we're going to simplify this by rewriting this as plus or minus, well, it's 4 times 5, so it's the square root of 4 times the square root of 5. So this becomes x equals plus or minus 2 square roots of 5. So now let's solve something a little bit more complex. Notice here that we now have an entire piece in parentheses squared. So our goal here is still going to be to get the squared piece alone, because in order to undo that squared, we need to square root. So notice that regardless of whether or not it's x squared or it's a parenthesis piece with a squared around it, these are still quadratic equations, and our goal is still to get that squared piece by itself so we can undo the squared. So we're going to start here by undoing this multiplication of 6, so we're going to divide both sides by 6. As a result, we end up with, in parentheses, x minus 4 squared is equal to 9. Then from here, I'm going to undo my squared because my whole piece that is squared is alone. So I square root both sides. So I end up with x minus 4 is equal to, remember, square rooting a squared means that we're going to have both a positive and negative version of the square root of 9. Now, hopefully you're thinking, well, the square root of 9 is a perfect square. So what we're going to do is we're going to write this as x minus 4 is equal to plus or minus 3. So we are accounting for both positive 3 and negative 3 that when squared give us 9. Now, I still need to get my x value by itself, so I'm going to add 4 to each side. So we end up with x equals a plus or minus 3, and then both of those added to 4. Now, because we don't have any square roots in this problem, we can actually take this one step further and find what x actually equals. So I'm going to take this further and help you figure out what this notation actually means. This notation with the plus or minus is saying x is equal to two things. X is equal to a positive 3 plus 4, which in this case gives us x is equal to 7. Or x is equal to a negative 3 plus 4, which has x is equal to 1. So we have two answers for x here. X is equal to 7 or x is equal to 1. And if we were to take either of these values and put them back into this original equation would become true. So let's work through another example together. Remember, our goal is always to get this squared piece by itself. So we're going to start by subtracting 1 from each side. So we have 3x minus 4 quantity squared is equal to 120. Divide by 2, and we have 3x minus 4 quantity squared is equal to 60. So we get that squared piece all by itself, and then we undo the squared by using a square root. Remembering that when we square root a squared, we need to set 3x minus 4 equal to the positive and the negative version of the square root of 60. Now, because we have a square root here, we need to simplify that square root. And if I look at 60 and I start dividing it by the perfect squares, I find that the only perfect square 60 is divisible by is 4, and it's 4 times 15. So what we're going to do here is simplify this a little bit. So this becomes the square root of 4 times the square root of 15, which is plus or minus 2 square roots of 15. So here we have 3x minus 4 is equal to 2 square roots of 15. Now, in order to figure out what my value for x is, I need to get x by itself. So what I need to do from here is I need to solve for x. So I need to get this x value completely by itself. So I'm going to start by adding 4 to each side. And so that makes it 3x is equal to plus or minus 2 square roots of 15 plus 4. And then we're going to divide both sides by 3. So I find that x is equal to plus or minus 2 square roots of 15 plus 4, all divided by 3. Now, you can leave your answer like this. This is something I would take. If you'd like to write them as two separate answers, you would simply write x equals a positive version of 2 square roots of 15 plus 4 over 3. And then you'd have the x is equal to negative 2 square roots of 15 plus 4 over 3. So you'd account for both the positive and negative version. Either one of these answers is okay. It doesn't matter to me how you want to write your notation, if you want to write it as a plus or minus, or if you want to write it with the positive version and the negative version. It doesn't matter to me. The big thing here is this needs to be written in this simplified square root form. One of these two. It cannot be written as an approximate rounded decimal.